Thank you. I'm regaining my hearing in my left ear.
Shut up and continue.
Yes, I will. Thank you. So, from my perspective, I think application development on Azure has kind of become boring. I was talking about this topic when the Finnish Azure User Group was founded in like 2013 or 14 or something like that. Yeah. That was hot then.
That was the last time we invited you.
Yeah. I don't know why I'm here now. Anyway.
So he has come uninvited all the time.
Yes. All right. All right. So essentially what I think Azure is too ready for application development. I mean, of course, there are little things you would want to change, but essentially whatever kind of software you want to build, you can do it right now. Those pieces are there. There are best practices. You can learn them in Microsoft Learn or whatever. That is not super interesting. We can always talk about some niche scenarios where we have those exciting war stories. But I was kind of thinking, let's spend these 35 minutes talking more about this additional impact or alternate identities or awful irritation or whatever you want to call it. It's AI. So how that's changing sort of the software development life cycle as a whole. And this is going to be grounded on Azure, but we're going to be talking about how or how software development as a job is going to change. And I think the key change that's going to happen is that we're all going to be so much more full stack. So when we got public cloud, my first initial message is that the public cloud is going to make us more full stack developers than we were ever before. So back in the day, full stack meant building the back end and the front end as software. With the cloud, we have become builders of networks, firewalls, service buses, databases, because all that is something software developers are good at building when we can build it just by writing code or using IAC or whatever it is. With AI, we're going to be even more full stack than ever before because everything is becoming more abstract. So that kind of is just blowing our minds in the sense that we have to understand larger wholes of building business value. And that was actually, I think Vesa had an excellent slide, which was something like go from building using some tools to actually building business value. And I think that's a summarization of this presentation as well. One slide about me. So I'm Jouni Heikniemi. I'm a Microsoft Regional Director. Currently unemployed, as Sakke wants to mention in every one of my public appearances. Yes, retired. So I quit my job as the CTO of Norin in the end of January. I wanted to spend half a year thinking about AI and its practical AI readiness in companies. So essentially what I'm doing is I'm thinking and writing on LinkedIn and writing newsletters and maybe thinking about writing a book and stuff like that. It has been an interesting time because quite honestly, I used to have those 40 meetings a week. Now I don't. And I still don't think I have enough time to track everything that is happening in the world, just in this AI field. So if you feel that it is hard to stay up to date, it is super hard.
Is your advice start with unemployment?
Yes. I think that is actually a pretty standard way to start in Finland right now. So I'm trying to be part of the phenomenon. All right, let's get to, but by the way, the mere existence of this image is kind of an insane marker of where this AI has taken us. So building this kind of image would have taken hours or even days in the times of Photoshop. I wrote one prompt and uploaded one image of me in a suit and it turned into this. So that's kind of insane. Let's talk about software development, and the software development is best started by talking about NetHack. Who has been playing NetHack? A few, excellent. The rest of you can also be civilized. NetHack is this awesome ASCII graphics game. Sometimes credited as one of the best games in the world. Extremely complex game engine, but it's very simple in terms of graphics. Why I'm mentioning it here is because this has been a hobby project of mine for the last 30 years. Because when I was a kid, I had a strong crush on NetHack. And I have been rebuilding NetHack time and time again by writing the code myself. I've been doing it for various reasons. I've been doing it to learn new programming languages, new programming paradigms, testing new libraries. So the first NetHack clone I wrote was, I think, 92 or 93, so 30 years and something ago. It was written in Turbo Pascal because I wanted to learn object-oriented programming. I have since done the same exercise, building a game engine like this to learn not just objects, but also different kind of graphics libraries, C#. I did it once using some functional language I've already forgotten. This might be my 10th time around doing NetHack. And I've now done 2 iterations of NetHack clones using LLMs or AI development. Stormhammer 7, because the last like 8 of them have been called Stormhammer. Stormhammer 7 was built last November using what model did I have them? I think Claude Opus something. It sucked. I got somewhere, but the graphics were nowhere near this nice. The pathfinding algorithms, the level building, it sucked. Stormhammer 8 was born last week. It started with a simple prompt like this. You are not expected to read it. That is a prompt for a NetHack-like game engine. It does not specify objects. It does not specify monsters. It does not really specify how you interact with objects in the dungeons. But anyway, you essentially have a game engine for building something that is a text graphics-based adventure game. What happens next is I hit enter. It gives me this plan. And then I say autopilot implement everything. You only live once mode. And then I get back something that cost me 7 premium requests, or about $30 cents, or about 7.5 minutes of API time. The session length was 6 hours because I spent a meeting in between. But anyway, in about 8 minutes, it built me this, which does not look as good as the real thing, NetHack, which has been built over the last 40 years. So it's nowhere near as good. But this took like 7 minutes to build. And if I compare this to my previous 10 iterations, I think I would have been like doing this for maybe 2 or 3 days, because building all that corridor pathfinding and all those things is not super simple. And you can also see there are early things. So that @ sign there is me moving around in the dungeon. It has some sort of a shadow casting. So there is an area I can see and there is an area that is unlit. So this kind of explains how much I can get done with a single prompt. Now I throw in 8 more prompts and maybe 1 hour of my time, and I'm already much further. So now I have a character sheet. So there are these D&D style character stats. I can open and close doors, search for hidden doors. I can move up and down stairs. I can run. I also have an inventory. So I have built essentially a scaffolding for a full sort of an adventure game, and I spent an hour doing it. I spent about $2 worth of tokens doing it. That is insane. For somebody who has been starting this application from the start like 10 or 15 times during the last 30 years, I can now do it in an hour. That's almost taking the fun out of it. So the software development life cycle of 2026 is really changing. The coding part is something we are really looking at changing, because that is the AI-assisted development, or whatever you want to call it, using Claude Code, using GitHub Copilot, whatever you want to do. This is changing at an insane rate. Essentially, we are all thinking about requirements. So that is kind of the big change that is happening here. I used to think about those corner painting algorithms. I used to think about shadow casting. I used to think about optimizing that double buffering algorithm so that the console window doesn't flicker. I've done that too, quite a few times. Now, I'm more into things like spec-driven development. So essentially, if I look at Stormhammer 8, this about 1 hour old project, what I have there is that I actually have a directory full, or a nested directory full of markdown files, and where I specify how I want this application to work. For example, when I want to implement open and close doors functionality, what I did is I actually opened up a new markdown file and I wrote the spec. I want doors to behave like this. I literally did nothing else. I have actually never even touched the source code. I have looked at it in terms of quality control, but I have not written a single character of C# in building this. My initial prompt was just build a NetHack clone on a .NET 10 console app basis. And then I started specifying the game functionality. And then what my prompt is, I have a clean Git directory, so a repository. I make this markdown file addition there, and then my prompt is look at the changes I made in the specification and implement them. Hit enter, wait for 2 minutes. Now I have open and closed doors. So my entire workflow has changed from writing code to writing specifications. And no, I'm not telling you this is how you can do every business application in the world or every critical production application in the world. There are complexities this does not capture. But this should explain to you how big the change is from a developer perspective. What this leads into is something that is a cousin to the AI slop we are talking about in the mainstream media. So we have this feature slop because everything is so easy to build. Why not build everything? The problem there is that we actually have to pay for all the slop we generate. So it's not just a question of how many tokens we waste every time we want to change the code. It is also a question of how complex the user interface becomes, how complex the system is to document, how complex it is to migrate from one solution to another because there are just so goddamn many features. So as developers, we're pushed into a space where we actually could easily implement something, but we still should not do it because it's going to cost us over the long run. In 1970s, Frederick Brooks made a research covering how much of the software development lifecycle cost happens at the project stage and how much of it happens in the maintenance stage. And even in the 70s, almost 80% of the cost typically is allocated to the maintenance stage. So whatever you do upfront in your initial project, it's only 20% of the total cost. With AI, the total cost of first implementation is shrinking. Now it's maybe 3% or 5%, but that 95% of the cost is still the maintenance phase. And maybe that's shrinking as well, but it's still a big part. So you should always think about what's actually worth implementing. So the developer's dilemma is that we are sort of being put between the product owners and the realities of maintaining a software that is so complex because there are so many features. So what are we going to do? Saying no becomes now a new core engineering skill. You need to be able to say no and argue why no is the right solution here. Because right now we are in an AI fever where everything we can do by burning tokens is great. So yeah, requirements. Now we have this part of design and architecture, how we're going to actually build it. This is a super large topic. We could spend a day talking about it. Just saying that there are a couple of different questions here. First one is, what's code design? So how do we control the style of the code we're writing? Do we even care? Perhaps we don't. By the way, if you want to take a picture of this picture is going to be completing over the presentation. You can take a picture of the last slide in the presentation. That's going to be better for that. Anyway, so I don't know if I care with Stormhammer 8 what kind of code it is writing because I haven't actually written the code myself. I don't need to touch it. Prompts have been taking me pretty far so far. But if I want to, and actually what has happened is that the system has itself generated a markdown file. This is built using GitHub Copilot CLI. So it creates a file called copilotinstructions.md. And that contains a rough description of what kind of coding patterns I want to use when building this application. It contains references to other markdown files describing the subsystem division of how an application like this is being built. And this is essentially crucial because if somebody wants to take a human look at the application, this is really something that helps. If you want to change something, for example, last night when building these slides, I would just decided I want to build a feature for that game as well. So I put a background prompt running that built me unit tests using XUnit and Fluent assertions. And I actually wrote in this file the spec that I want tests to be done using these and these libraries. And then I just said, bring me those tests. And that's what happened. So this is kind of one way to control the structure of the code that is getting generated.
So you're saying that Markdown is now a programming language?
Yes, and English. I am not super satisfied with where we are right now, but that is the reality if you want to be super productive in just building features, and if you don't have to control the result line by line. Yes, Markdown is a programming language. It could have been YAML or JSON, so I think we're pretty satisfied that it's Markdown. One next thing I want to highlight is the AI for visual design, because I have zero visual design capability. I suck at it. So essentially that's why I always do those text graphic games, because I can't come up with new visual ideas. But I'm going to be silent for about 1 minute and let you look at a video. That is actually an ad video of a company called Pencil.dev. Does anybody use Pencil? Okay, so essentially what it is, it's an AI-based service for building visual design. And what you're seeing here is a 1 minute sequence of giving a prompt like build me a CLI-inspired interface for a rocket launch monitoring dashboard. And look at how AI is building their visual design. There should be music, but we don't have it now, but don't worry. So what you're seeing is prompts on the left, then it's starting to build a user interface. And as the user interface grows, you're starting to see more and more elements come to life. So you would obviously be able to feed this Markdown specification as well. So I want this and this information to be visualized. And you're also seeing designer-like elements on the right panel, but it's still, you see AI doing its work. So this is how tokens get generated. So everything happens incrementally. And now you're seeing it move into more visual-like, so different alternatives are being built. There are human controls for changing how visuals can be changed. And then we're getting to the point where you're actually having this integrated with Claude Code, and then you're prompting like, build me a React Tailwind Node.js app from this visual, and then you get a web page out. So Pencil.dev is currently free, so this is not a commercial ad for anything. I'm not affiliated with the project in any way. But I think this is an interesting example of development that can happen, because look at how easily it happens.
Also, about the coffee thing you saw, there's a YouTube clip where they do it, live. So you can really get into Pencil quite easily. They understand the way we learn nowadays, which is videos. I checked it. It is pretty convincing, this Pencil.
Yeah. And my point is not that you should necessarily use Pencil, but the point there is that if you have something like a design system or a graphics guidelines or whatever it is, and you always need to replicate the same UX design patterns using whichever toolkit you have on building your UX, you don't have to do it manually in the future. I'm not sure if Pencil is ready to be implemented in every project, but this is kind of the direction where we're going. So creating new things and creating actually even good-looking things, not just my NetHack clones, is getting easier and cheaper all the time, and that's really insane. All right, so where this is leading into is sort of a code explosion. So currently, I think the numbers are from early this year. 51% of developers use AI tools daily. Most of them use, I think 86% of developers use AI tools every now and then, so most use. I am not sure how effective we are in that. I think that's a topic for an entirely different discussion. But 2/3 of developers feel that AI helps them adopt new technology or languages, which is also interesting because it allows us to be way more versatile in what we can develop using just our existing skill set. But also, 46% of developers do not trust AI accuracy. And I think I'm not trying to hype here. I am trying to give you a picture of the future. I don't think anyone here should think about what's possible with AI or what's not, because that's not a realistic way of thinking about things. What used to be impossible with Claude Opus 4.0 was possible with 4.5. What failed with 4.5 is now easy with 4.6. And actually, those Stormhammer 8 room corners, I don't know why the room corners are so difficult, but they did not work in December. They work fine in February and March. So evolution is happening all the time, and what's possible today is a small subset of what's possible half a year from now. So we should think about these things as coming to our everyday lives, even if what we do today is not right now possible. And this trust for AI accuracy is a good thing to have. So we're getting into new kinds of things. And I am not sure how big these patterns are going to be because we have just so little experience. Because from my perspective, this AI-assisted software development became serious in December with the launch of the Claude 4.5 models. So we're talking about a 2-month-old practice. I am not super impressed with the data we have so far, but we're getting there. I think the anecdotes, the personal experiences are impressive. But what's happening is things like this. For example, if you have a team of developers, maybe all of them are not working on the same files, and that's a good thing, because agents, if you use agents for development, they are writing code so fast that it is very hard to resolve all those merge conflicts. So if you have a team of few developers and they all use agents, you should probably separate who's working on what, because you're never going to be able to deal with all those commits and all those pull requests and all those merges. But that brings an interesting question. Are we starting to build architecture for the sake of separating our development time tooling, even if that architecture does not make sense in the runtime? And I think we're going to be seeing this. I have seen some examples of this so far, but it's going to be interesting whether it's going to be a pattern for a year or 2 or 3 to come. Because we don't need to do microservices because different developers want to work on the code at the same time. But that is what easily happens because it is just so fast to spin up a new process. Let's be careful for this. Specification quality is another thing. I think the vast majority of world's applications do not have good documentation. If you build your apps like I built my NetHack clones, your apps are going to have excellent documentation because I have never done anything else but write that documentation. And actually, I didn't say it before, but I'm going to say it now. Sometimes I have realized that my documentation sucked For example, I asked the agent to plan something regarding how does run work in the dungeons. Then it points out several corner cases I hadn't been thinking about, asks me, how do you want these to be resolved? I say, okay, do it like this and update my specification. So actually the spec that ends up committed is better than the spec I wrote. So yeah, we're getting there, the specification quality is getting better. Now the question is, are we going to be able to deal with the quantity? So the LLMs are getting better at dealing with a large quantity of markdown files describing the application, but are we as humans going to be good enough at understanding what the applications do, especially if there are so many features? So I think we're going to have to be doing human work as well, building sort of indexes to finding where is exactly the right specification for this, the app or what feature or whatever it is. And third one, I think we're going to be doing a lot of soul searching. First, how we as humans behave in this new economy of software development, as well as the best project model, because how is this going to change things? If one person can do the job of a team, how is that going to change things? The first real question, I think, is AI brain fry. So if you try this agentic software development, who has been trying to do 8 hours of agentic software development? Okay, how did you guys manage?
Not well.
Yep.
Well, you fry your brain.
Yeah, I think 3 hours is pretty much what you can do. 3 hours and your brain is fried because the cognitive load of constantly writing better and better specs and prompts and then verifying the results, looking at those 1,200 line pull requests and oh my God, it is very hard to do well. So I don't think we can do 8 hours of this. My strategy is that it's sort of a drug. So when you write a prompt and it generates you excellent features for your application, you want to write one more prompt. Okay, that's hard because you never get to sleep. I think my compromise is that you write the prompt, but it takes like 5 minutes to run. So in between that 5 minutes, you take up civilization and you play one more turn of a strategy game. When you get that turn done, oh, my prompt has completed, now I can do another. And when that prompt is again running, then you play another turn of the civilization. So that way you can get two kind of excitement for your brain. I still don't think you can do 8 hours. And I'm not sure your employer is ready to pay you for playing civilization, but you could try it if you're unemployed like me. Anyway.
My feeling exactly. When you do development, you feel like playing civilization.
Yeah.
You just want to do one more round.
Yeah, exactly. But it is quite different to play civilization than doing development, so you can do them side by side. But yeah, the addiction is the same. I agree. Okay.
I have a question.
Go ahead.
I forgot researcher, but their statistics showed that out of the AI users, basically 87% or 9 out of 10 users will become passive.
Yep.
The information the AI gives. And isn't the very indication that the brain right now for that? And how are we to prevent in a working environment that people don't take the AI so for granted?
That is so sock-worthy a question. But I'm not going to answer it here because the answer would take like 5 or 10 minutes. I think that's a great point. And if you start discussing that, you should separate using AI for things like information retrieval and using it for creation, because I think those are fundamentally two different thinking modes. Let's talk about that in the break if you want. Sorry, I have a time limit here. So the definition here, I think for the AI brain fry is the fact that we are not able to cope with the problems AI is throwing at us at the rate it's doing it. And if you look at these, the numbers seem small. 14% of workers report mental fog. I think this is because people don't use AI for really complex things. I think we had like 4 hands raised in this room when I asked who's doing agentic AI software development. If everybody in the room did, I think most of you would be like, oh yeah, and I'm so fried about it. So these numbers are going to grow as AI adoption grows. The paradox here is that AI makes us so much more efficient, but it pushes all the cognitively hard things on the human. And I think over time we're going to be finding ways to have agents verify each other's work so that we don't have to verify everything by hand. I think that can happen, but I don't think we're there yet. And I think currently expecting somebody to do 8 hours of agentic software development is insane.
Where we are though, I think, just as a side note, is the playwright note that I said earlier, that you can have the AI run the playwright and your user interface tests. So the AI can already do some of the validation.
Yes.
Just not all of it.
Yes.
And you don't know where it breaks down, which is the issue, I think.
Yes. You saved me one slide, but thank you.
Sorry.
One question I get, I actually got it from my wife, who's also a very senior software developer by trade. So She asked if I see this as the waterfall model making a comeback, and I want to be specific about this because even if we're writing so much specifications, it does not mean we're doing waterfalls. So waterfall model was described by first having a requirements analysis, then going to technical specification, and then implementing everything, then quality testing, and then doing this all over again if we ended up doing the wrong spec. That failed because we cannot predict requirements up front. That is a different problem from doing this spec-driven development. So with AI development, the good thing is you can do a very small spec at a time, or you can do a large one if you're able, but you don't have to. You can do small parts at a time. Humans are architects in a very fast feedback loop. The problem is that that feedback loop is so fast that it's tiring us, but it is still great for the terms of building the result. Spec sort of is the product. So as I said, my markdown files are in the repository, and they are essentially the source that AI uses to build the application. The spec writing muscle, if you were good at writing specs like 10 or 20 or 50 years ago, that is actually super valuable again. Not that Agile is going to die or anything, but we are going to the world where specifications are far more important than this just sort of an ambient understanding of what software should do. Good. I'm gonna mostly skip the quality part. What I was gonna be talking about here is that we can go so far with the automated test generation and so on, but we are running short on time. That one highlight that Saki already mentioned is this Playwright. So if you have not used it, Playwright is a library or a system that runs browsers, so enables web user interfaces to be used using agentic tools. So this is cool because if you plug in Playwright to your development agent, that enables your development agent to look at the user interface and make determinations of whether the changes were correct, build automated UX testing suites, and so on. So you could, for example, say, move this piece to the left until it aligns with this, and it's able to visually verify if it looks correct. So that is great with Playwright. You should look at it if you need it. I'm going to spend a few minutes talking about ops, because I think that is something that deserves even more attention. We just don't have the time, and I don't think the products are mature enough either. But this is getting more into the Agile territory. So the first 4 stages we talked about are development in general. We are describing business features, we are describing technical requirements, and we are building the software itself. Now we need to deploy it somewhere, and we need to see if it's running. So essentially we are talking about Azure on the right end, and it works great for that. There are quite a few innovations in this space. I don't think any of them are super mature yet. I would like to see this evolution. I think this year is going to show us a lot. The one I am going to mention, but not demo here, is the SRE agent. So SRE, I don't know, how many of you do SRE? Not even without explaining the abbreviation. Okay, a few. So now I'm going to explain the abbreviation. So SRE is site reliability engineering, sometimes considered a sub-practice of DevOps. So what it essentially means is building tooling and automation that helps you run complex applications in production where you know that things are going to go to shit anyway. Things are happening. This service there crashed. That production upgrade there did not work perfectly. You still need the whole big system to work. So SRE is a practice that things like Google, Netflix, and so on do heavily because their systems are insanely complex. You just need to build a very resilient and robust system for running them in production. Almost nobody really does heavy-duty SRE by hand, but there have not been many products for doing this easily for a smaller scale system. Microsoft is working on one solution, this SRE agent. Google it if you want more details. There are a couple of good YouTube videos as well. So essentially what it is, it's an additional service both on your Azure subscription. What it does, it automatically monitors your application. You can give it sort of a run books. So if you encounter a problem like this, start executing it, these instructions. But it is powered by an LLM. So essentially it all the time it's looking at your instructions, your source code, your documentation, and trying to reason about what's really causing this problem. It may encounter issues it cannot fix by itself, but if it is a path that it can fix itself, it will do it. So that's kind of an insane that you can have this midnight production breakdown and 20 minutes later, it has been fixed. You still have a ticket waiting for you on the morning, but it has been resolved. You still need to document, you still need to understand what has actually happened and maybe do the corrective actions, but things have started happening already. So for example, it can use your ServiceNow or whatever to post your tickets on what has actually happened in the systems. I think this is important because as we grow in this architectural complexity, the systems are getting harder and harder to monitor by yourself. Also, we are expecting more and more reliability every week, every month. So getting the AI into the game is going to shorten our downtimes. But my personal experience with the SRE agent is it's not ready yet. But I think it is evolving in an interesting direction, and I think every build conference from now to the future is going to be providing us some information on this one, because this is really a crucial extension for getting that AI into the full SDLC. All right, there are so many topics we could be talking about. So we didn't talk about the whole complexity of should humans always review code written by AI. There is no one single right answer. I kind of like humans reviewing, but I don't like being the reviewer, so that's kind of the problem. Can we do security reviews fully automatically? Claude Code Security made a splash in February. Maybe in the future, we don't know yet. As Saki already mentioned, spec-driven development is a field that is evolving very fast. We are getting the tooling there. How can we build the specification libraries for really big applications, not just simple games? You can't just have markdown files. So those are getting really, really complex. We didn't talk all about parallelism. So if you want to run like 7 development agents at all the time, or if you want to split your workflows so that you have one agent that is verifying your database integrity while another one is building the UX and so on, that is a field that is so much is happening there. It is hard to give any guidance, but I think these are the kind of the problems that we are going to be facing as developers. Automated development, you maybe know that in GitHub, if you buy the right licenses, you can already assign tickets to something called a copilot, and they will start fixing the bug itself, and it will just give you a PR. Okay, review this. If you give the PR comments, it's going to fix the bugs you mentioned, and when you're satisfied with the PR, then it's going to commit them and merge the branches. So we are getting into these things where the development is being split between humans and AI, and that is really hard to understand. Okay, now, this slide, and I think this may be the time where you want to take the picture if you want. So that's the full SDLC. I think the software development lifecycle, as we have understood it in the past years, is evolving into this understanding of software factories. I'm not sure that's the term that's going to stick, but essentially the first 2 stages of the SDLC are going to be turning into a specification phase where we are going to be specifying architecture and business requirements in ways that are quite different from what they used to be in the past. Then we're going to have this manufacturing part. I intentionally wanted to use that term because it does not feel like development of the past. It is more manufacturing in an industrial sense, so very repeatable processes over time. And the operations part, which is running the continuous services. Now, the bottom line here is the actors. So we as humans are probably going to be mostly focused on this part, understanding the requirements and writing specifications, more or less technical, depending on the needs. AI tools are going to do this one, and the cloud, Azure, for our perspective, is going to be running this operation more and more. I think this is going to result in some very interesting transactions in what's happening between these arrows, because, for example, right now, Microsoft has been, and every cloud provider has been working a lot on the developer experience. They have been trying to build better and better SDKs, better and better portal views, so that we as humans can operate the cloud. But that is actually pretty clumsy. If we can have AI agents run the cloud, then it's going to change how the interface between the code and the cloud is going to work. So clouds may become more of a capacity provider because humans don't need to be so good at using them. And I'm not sure is this going to be a good thing, but I think that is something that is already on the horizon. The quality control here, who is looking at what's going to be pushed into the cloud? That is hard. This is the actual final slide. If you want my career tips, these are the skills that are losing their value on the left and skills that are increasing their value on the right. Essentially what I'm saying here is that communicating, leading, being able to negotiate features, verifying that something actually meets the business need, that is the crucial element of being a good software developer in the future. I don't think you can go on without technical skills. I still think you need them. It may be that in 10 years things are going to change, but I think those solo work marathons, coding by night, that's going to be a thing of the past in the profession at some point. Just start thinking about leading. How can I scale my work and my thinking? Because the world is sort of an insane one. Thank you.